Hello, ladies and gentlemen, and welcome back to the Pipe gDAO podcast. Today, we're going to be talking about SysTang, which is a project that we have on our platform, which is a sensor device that allows the detection of seismic waves through a wide range of frequencies, capable of communicating data signals in real world time, not fake world time. What this means is it's basically an earthquake prevention device. It can detect seismic waves, even predict earthquake patterns, predict seismic activity, whether devastation is going to happen or not, which, I mean, we see all the time. There's many different examples of earthquakes and seismic activity devastating communities. For instance, I remember when I was younger and I was watching the Japanese tsunami absolutely wipe out most of the coast in Japan. It was horrific. Um, yes, but anyway, we've actually written a story here to basically say what the Earth could look like in 20 years if things continue the way they're going. Obviously, Seismic fails in this future because the gDAO patrons, such as yourself, didn't invest in it and didn't promote this new forward-thinking seismic activity detector, which is very real. We know seismic activity is real. There's no doubting it. We've seen earthquakes. Many of you, I'm sure, have felt earthquakes. Seismic activity is real. So, in the year 2045, Earth teeters on the edge of collapse. Seismic activity has become more frequent and devastating due to a climate change and shifting tectonic plates. Cities such as Tokyo, Los Angeles, and Istanbul are constantly on the brink of disaster. Their outdated warning system unable to keep pace with nature's fury. The wealthy live in fortified enclaves, safe from the chaos, while the less fortunate struggle to survive in crumbling slums. Corporate tycoons and corrupt governments maintain their grip on power through manufactured crisis, deploying mercenaries to sabotage emerging technologies that threaten their dominance. Amidst this turmoil, a catastrophic 9.8 magnitude earthquake strikes the Pacific Ring of Fire, obliterating coastal megacities and unleashing tsunamis that wipe entire nations off the map. The global economy collapses. Millions perish. Among the survivors in Los Angeles is Aria, a brilliant but grieving young engineer who has lost her family in the disaster. While scavenging through ruins, she stumbles upon fragmented research on an abandoned technology, SEISTENG, an advanced seismic detection system capable of real-time 3D mapping and predictive analysis. Had it been fully developed, it could have prevented the devastation. This knowledge ignites a fire within her. She must recover SysTang and bring it back to the world. But fear grips her. Governments are in disarray. Corporations hoard resources and lawlessness runs rampant. Those who once funded SysTang were silenced or eliminated, their research buried. Aria wonders if she has any chance against such insurmountable odds. She is ready to give up when she meets Dr. Elias, an aging seismologist who once worked on the project, living in secrecy. He entrusts her with encrypted blueprints, teaching her the true potential of SysTang, a future of zero casualty cities where disasters no longer dictate human fate. Inspired, Aria resolves to act. Leaving the ruins of Los Angeles, she joins a resistant movement of scientists, engineers, and survivors who still believe in a future free from corporate tyranny. Together, they navigate the wastelands, seeking allies and lost knowledge. Aria faces brutal tests, crossing treacherous fault lines, hacking corporate firewalls, and surviving deadly encounters with mercenaries. Along the way, she recruits a team, a rogue hacker, a fearless community leader, and former Pipe gDAO members who once dreamed of decentralized earthquake prevention. Their journey leads them to Iceland, where a volcanic eruption has buried the last SysTang prototype. Battling unstable ground and relentless corporate drones, they unearth the facility, only to be caught in a massive earthquake. While the prototype only partly functional, Aria risks everything, uses its incomplete data to guide her team to safety while sacrificing critical equipment in the process. She barely survives, but the ordeal transforms her. She's no longer just an engineer, she is a leader. While the recovered SysTang prototype, Aria unlocks its full potential: global seismic monitoring, AI driven predictions, and LOT integration. But she also discovers something more. Pipe gDAO's original mission was to fund such innovations through decentralized means. This revolution sparks a global movement. She shares SysTang's data across a revived decentralized network, rallying the people against corporate control. The world begins to change, with early warning systems saving thousands. The elite grow desperate. As Aria influence grows, corporate forces orchestrate one final, desperate attack. At a global summit means to debate SysTang's implementation, they attempt to manufacture a seismic catastrophe, aiming to discredit her and the technology. But Aria, armed with SysTang's real-time detection, predicts the quake's path and orchestrates the evacuation of millions. In a dramatic climax broadcast worldwide, she exposes the corporation's sabotage, shattering their control and proving SysTang's effectiveness. Humanity stands at a turning point, with SysTang developed worldwide. Earth's cities become resilient across natural disasters. Communities are empowered through Pipe gDAO, ensuring that seismic technology remains in the hands of the people. Economic prosperity follows, and hope is rekindled as Earth stabilizes. The potential for interplanetary expansion even becomes a reality. Aria has not just saved lives, she's reshaped the world. She returns not as a mere survivor, but as the architect of a utopian future, one where humanity no longer fears the earth beneath its feet, but walks forward with confidence towards a new era of unity and resilience. So, obviously, there we're covering a dystopian hypothetical. Now I'm going to sort of drop some real time, real world things. Some of these instances happened only yesterday. Um, what I mean with yesterday was in California. There was two earthquakes of a magnitude 4.0, with the first quake struck at 7:13 p.m. It was 14 miles from Potter Valley. Again, this was yesterday. It was detected because America, they do have detection systems, but ones that weren't detected and was very devastating was one on the Turkey-Syria border. I remember this. It was on February 6th, 2023, and it caused over 20,000 fatalities and extensive infrastructure damage. I still remember seeing the Red Cross, everything. It was all over the news a couple years ago. It was brutal, really brutal, devastating stuff. And what we're talking about when it comes to SysTang and this sort of prevention, allowing detection of seismic waves through a wide range of frequencies, it's a prevention method to stop situations like this happening. I even mentioned the sorry, I even mentioned the tsunami in Japan a couple years ago, which just devastated the country. It was all over the news. It was brutal. It was even felt, I think, in coastal China and places like that. It was devastating. So we're sort of trying to push these are SysTang at its biggest potential, its maximum potential. SysTang, which includes a instantaneous global warning with SysTang sensors, hopefully with the help of Pipe gDAO patrons, being strategically placed across tectonic plate boundaries, urban centers, and rural areas, detecting earthquake precursors and seismic waves instantly. So it's using an advanced machine learning, and with the system being able to predict earthquake magnitude location and help impact with near perfect accuracy, providing some real time warnings to every individual via their smart devices. public alert systems and LOT enabled infrastructure up to several minutes or even hours before the shaking begins. Now, if you go back and you think about the Turkey and Syria border, 20,000 fatalities, if they were given 7 minutes to an hour heads up, maybe that number wouldn't be so catastrophically high. We could always also have a zero casualty cities, which would be hypothetically, of course, cities are retrofitted with SysTang, which will be integrated within the smart infrastructure, including buildings and bridges and transportation systems, equipped with adaptive dampeners and base isolation technologies. When an earthquake is detected, SysTang could automatically trigger safety measures. So elevators stop safely, trains will halt, and buildings dynamically adjust to minimize the shaking. This can ensure no loss of life, even in densely populated megacities prone to seismic activity. Those cities, obviously, including Tokyo, which is a big one that I've mentioned, Los Angeles in California with the earthquakes just yesterday, and Istanbul in Turkey. So, community empowerment and resilience it can also produce. So, communities are empowered through decentralized, transparent platforms. This is a shameless plug by the like the Pipe gDAO, of course, that funds and manages SysTang developments. Again, SysTang is a project on our platform that you, as a patron, can contribute to right now. Every citizen will have access to real-time data, educational resources, and emergency protocols via a user-friendly app. Post-earthquake, the system coordinates rapid response using sensor data to guide search and rescue operations, optimize resource distribution, and rebuild infrastructure with resilient anti-seismic designs, fostering global unity and collaboration, as outlined in the web results on earthquake resilience and urban planning that we found in our own research when doing this podcast. It can also trigger environmental harmony. So SysTang's adaptability will not only allow it to monitor earthquakes, but also volcanic activity and landslides. This can be vital in countries like Iceland, which are mostly volcanic, creating a holistic Earth monitoring system. This data can also help scientists predict and mitigate natural disasters, preserving ecosystems and reducing human impact on vulnerable regions. The technology will help integrate with renewable energy grids, ensuring sustainable operations without environmental harm. Economic and social transformation as well, with earthquakes no longer posing a threat. Global economies can thrive without the burden of disaster recovery costs, which is estimated to be billions annually. Insurance premiums drop, investment in high risk areas can surge, and societies redirect resources towards innovation, education, and healthcare, creating a more equitable and prosperous world. Pipe gDAO's investment model democratizes funding, allowing communities worldwide to contribute and benefit from this technology. So this is what we were talking about with SysTang at its full potential, creating a basically shield around the world, or not a shield, a monitoring system around the world, which will be able to detect and warn people of seismic activity. Again, this is all on our platform right now. If you go to the launchpad, you can see SysTang among the many projects that we have up there. We're going to be hopefully covering more of these projects in the pipe in this podcast. Now, if there's anyone that has any comments on it or they want to know more about SysTang, you could go to the pipegdao.io and click invest. That will be an investment into the PGF to become a patron of the platform. All your information through there. You can also maybe join our Telegram and ask our people. We've got everyone in there, including the lab to IPO people. We've also got people like Batsy and Wayne, who are Batsy obviously being a main founder of the PGF Launchpad himself. I'm in there. Any questions, any notes you have about the podcast, I can see directly, all on Telegram or Discord, where Ruth and Bajrang work in. So if you have any comments, any tribulations, anything like that, please let us know. We have a link tree in the description. So yeah, I hope to see you all next time, and I hope you enjoyed this podcast and listening to Earthquake prevention methods, something that still is seriously lacking in today's standards.